triangle ADB is congruent to triangle ADC by RHS criteria. Now, since they are congruent, so by CPCT, all the corresponding sides and all the corresponding angles are equal. So by CPCT, side BD is equal to side CD, right? And so in terms of question, you can write that AD bisects BC, or you can say that AD bisects BC, right? And also angle 3 is equal to angle 4 by CPCT. So like two things you can show by CPCT. So first thing is this, and second part is this, that angle 3 is equal to angle 4. And or you can say that AD is the bisector of angle A. Correct?
Yes, ma'am.
Yeah, please note it down. Done?
Yes, ma'am.
Okay. Now third question. So here's the question, that two sides AB and BC, okay, and median AM of one triangle are respectively equal to this, okay. So basically this side is equal to this side, it is given, right? So write down whatever is given here. So first of all, AB is equal to PQ, clear? Okay, and BC is equal to QR. So BC is equal to QR, right? And the median AM. So median AM is equal to PN. So these three sides are equal. Okay, and you have to show triangle ABM. Can you see ABM? That means this triangle, okay, is congruent to triangle PQN. Like in the first part, you have to show this. So PQN is this, clear? How will we do this? Now see here, if you look at the two purple triangles, the left triangles, okay? So already two sides are equal. I like this side is already equal to this. It is given, clear? Okay. And other side, this side is already equal to this side. It is also given, isn't it?
Yes, ma'am.
Okay. Now we need this side to be equal to this side. But in the question, the complete side is given, like complete side BC is actually equal to the complete side QR. So we have to convert this into this half side BM is equal to QN. How we will do this? So it's simple. Now in the question, it is given that AM is the median. Like what is the definition of median? Median means this point M divides BC into two equal parts, right? That is the meaning of median. Median means it divides the other side into two equal parts. So I say that AM is the median, clear? So median means BM is equal to CM, clear? Which is just half of the full side BC, isn't it? Okay. And similarly, in the other triangle, PN is the median. So that means QN is equal to RN, which is half of the full side QR. Is that okay? Yes?
Yes, ma'am.
Okay.
Yes, ma'am.
Now, the side BC is equal to QR. This is given to you, correct? So if you just multiply by half on both the sides, so half of BC is equal to half of QR. Is that okay? Now, what is half of BC? As you can see here, half of BC is BM. So I'll take BM. I'll not take CM because I'm interested in the left triangle, correct? So instead of half of BC, I can write BM. And similarly, half of QR, I'll write QN. Is that okay? Because ultimately, I'm interested in the
Yes.
left side of triangle. Okay. So mark it as result 1. Now you come to the two triangles which you have to show congruent. So in triangle ABM and triangle PQN, right? Now you take them. So in the question, the two sides are already equal. Okay, it is given. So AB is equal to PQ and the median AM triangle PQN. Please note it down. Yes, written.
No, ma'am.
Okay, now second part. Yes, Zeba, I think you joined late, right?
Yes, ma'am.
Right. So let us come to second part. So have you understood, Zeba?
Yes, ma'am.
Now second part, same question. So I'm just copying the figure again. Okay, so in the second part, you have to show triangle ABC is congruent to triangle PQR, right? That means the complete triangle you have to show congruent. Is that okay? Okay. Now, just remember what was given to me. So it was given that AB is equal to PQ, right? That means this side is already equal to this side given in the question, right? And because I'm interested in the complete triangle now. So this complete side BC is already equal to QR, right? So at least two sides I already have. Okay. So either I can have SSS criteria. Okay. Now, can I show AC is equal to PR? But nothing is given about AC and PR, right? So this is, I cannot use SSS here. Okay. I have to think of some angle now. So when we have two sides, like what is the criteria which is remaining? It is SAS, isn't it? So think of some angle which we can show. Now, because in this triangle, now try to understand this side and this side I'm taking. So I need this angle. Is that okay for SAS, the included angle? So can I show that angle B is equal to angle Q first of all, and then I'll say SAS criteria? That I can do. How I can do? I have already shown the smaller triangle, like this triangle is already congruent to this triangle in part 1, right? No, yes, no, you, no. I don't know whether you people are there or not.
Yes, ma'am.
Okay. So in the first part, we have already shown that this purple triangle is congruent to this purple triangle. Okay. So triangle ABM is already congruent to triangle PQN we have shown, right? So from CPCT, we can say, can we say angle B is equal to angle Q, right? Corresponding
Yes, ma'am.
angles of congruent triangle. Okay, so mark it result 1. Now you come to your bigger triangle. So in triangle ABC and triangle PQR, right? So now two sides I already have equal. So side AB is equal to side PQ and side BC is equal to side QR. Both are given. And then the included angle I have shown that angle B is equal to angle Q from 1. So that becomes SAS criteria, right? So by SAS criteria, triangle ABC is congruent to triangle PQR. I hope it's clear. Done?
Yes, ma'am.
Next question now. Okay, BE and CF are two equal altitudes of triangle ABC. So there's a triangle ABC if you draw, right? Okay. Now, what is it saying in the question? A, B and C, right? BE and CF. So BE and CF are two equal altitudes. So there's an altitude from here. I call it E. Altitude means this angle is 90 degree, correct? Okay. And another altitude CF. So one altitude is like this. And again, this angle is 90 degree. Okay. So what is given? Note it down. First of all, equal altitudes. That means the length is equal. So BE is equal to CF, right?
Yes, ma'am.
Okay. And if I call this angle 1, I call this angle 2. So angle 1 is equal to angle 2 is equal to 90 degree. It is given, right? Because it's altitude. Right. Okay. Using RHS congruence. Okay, it's already given. You have to use RHS. Prove that the triangle ABC is isosceles. Okay. Isosceles means you have to show the two sides are equal, right? So isosceles triangle is this, in which two sides are equal. So AB is equal to AC. This you have to show, correct? All right. Now how to do this question? See, it's already given. You have to use RHS. That means you have to take a triangle where one angle is 90 degree, right? Okay.
Yes, ma'am.
So can I take this triangle? BFC. See in the question, BFC. Okay, do the proof. So in triangle BFC, can everybody see that? BFC, I mean this triangle, right?
Yes, ma'am.
Okay. And triangle, this CEB, right? So RHS means one angle I have to take, and then this side I have to show equal, and then any other side I have to show equal. That is RHS criteria. So at least one angle is already 90 degree, which is given here. So angle 1 is equal to angle 2. BFC, yeah. Angle 1 is equal to angle 2, which is given. Okay. Now what is the hypotenuse? Which side is the hypotenuse in this right angle? C, right angle BFC. In this triangle, which side is the hypotenuse? Zeba. Okay, look at this purple triangle PQR, right? If this angle Q is 90 degree, which side is the hypotenuse in this triangle? Please unmute your mic, all of you. Zainab,
Yes, ma'am.
please unmute your mic. Jaslyn, Zeba.
Yes, ma'am.
Now tell me, in this triangle PQR, right? If
Yes.
Q is 90 degree, which side is called hypotenuse in this figure? Come on, if you have a right angled triangle,
PR.
everybody see here. Very good. So this, if this angle is 90 degree, so the side which is opposite to this, that means this side is hypotenuse of this triangle. Isn't it? You people already
Yes,
know
ma'am.
this. The longest side of the triangle is called the hypotenuse. You already, I mean, you have learned about Pythagoras theorem and everything. All right. Now you come back to your triangle BFC, right? So this angle 1 is 90 degrees. So which side is hypotenuse? Which side is opposite to angle 1? Okay, I'm not going to write anything unless you people will tell me. Come on, say it wrong at least, but say something. Zeba, unmute your mic.
Yes.
Now in triangle BFC, okay? Angle F is 90 degree. Sorry, this angle 1 is 90 degree. Tell me which side is called the hypotenuse of this triangle. Zainab,
BC.
why were you not speaking when I'm asking? See, unless you people will not respond, how would I know whether you are understanding or not understanding? Yes, Jesslyn?
Yes, ma'am.
No, yes, ma'am. Please respond to what I'm asking. You can give wrong answer, there's no issue, but please answer me something, okay?
Okay, ma'am.
Now this is a triangle. Now look at it like this. This is a 90 degree. So that means this side is the hypotenuse, isn't it?
Yes, ma'am.
So BC is the
Yes.
hypotenuse. So if you have to use RHS criteria, you have to show that the hypotenuse of the two triangles are equal. And BC you can see is the common side, right? In both the triangle. So BC is equal to BC, which is also the hypotenuse and it's common also, isn't it? So one angle is 90 degree. You write given 90 degree, okay? And hypotenuse is equal. Is there any other side which is equal in these two triangles? Always see what is given in the question. Go back to the given condition. I have written here, something is given. Zainab, is there any other side which is given equal?
No, ma'am.
No, it's written on the screen. Please open your eyes, all of you, please. I've already written two given conditions in this question. Can't you see this, everyone? Read the question at least. BE and CF are two equal altitudes. It's already given that the length of the altitude is same. They are equal. BE is equal to CF, already written in front of you. So BE is equal to CF, right? That means this side of the triangle is equal to this side of the triangle. So I have got one side which is equal, one right angle which is equal, and hypotenuse is common in this case. So by RHS criteria, the two triangles are congruent. So triangle BFC, is congruent to triangle CEB, correct? Yes. Okay. Now,
Yes.
if the triangles are congruent, so can I say that this complete angle is equal to this complete angle? Yes. Because in this triangle, this angle, and if I just split it like this is 90 degree here, right? So this angle will be equal to this angle, isn't it? Because the two triangles are congruent. So by CPCT, you can say angle B is equal to angle C, right? Now, if you look at the complete triangle ABC, right? In triangle ABC, so I have angle B is equal to angle C. So can I say that the side AC is equal to AB?
Yes.
Sides opposite to equal angles are equal, right? We have already learned this theorem. And therefore, triangle ABC is isosceles. Is an isosceles triangle. See, I always ask you people to unmute your mic because it's an online class. I cannot see you, right? At least you have to respond what I'm saying so that I know that you people are there and somebody is there. Okay, then last question of this exercise, even this chapter. Right. So ABC is an isosceles triangle. So there's a triangle which is already given here. Okay, with AB is equal to AC. So this side is equal to this side. Write down what is given here. So it's already isosceles. That means AB is equal to AC. Okay. Draw AP perpendicular to BC. So you have to draw a perpendicular line from here like this, right? And this is P. So AP is perpendicular to BC. This is also given. Show that angle B is equal to angle C. So it is like just the opposite kind of question we have just done. So in that question, we had to show that AB is equal to AC. Now in this question, AB is equal to AC already given. You have to show angle B is equal to angle C, right?
Yes.
Okay. Hmm. Now it is a right angle triangle as something is 90° already given, right? AB perpendicular means this angle is 90 and this angle is 90, correct? So you think of RHS in your mind. So what do you need for RHS? One angle has to be 90° in both the triangle. So if you take this like this triangle and this triangle, so one angle is already 90, right? Okay, then you have to show that the hypotenuse is equal. So which is already given. AB is equal to AC, correct?
Yes.
Is there any side which is equal here? The remaining sides are AP and BP, right? Which side is equal? AP is a common side, isn't it?
Yes.
Yeah, so AP is common. So one side also I have, so I can simply use RHS criteria.
ABP and
Yeah,
FPC
so take
is
them. So
congruent.
in triangle ABB and triangle ACP, right? So if I just name it angle 1 and angle 2, so angle 1 is equal to angle 2 is equal to 90°, which is given, right? Now hypotenuse, which is AB, is equal to AC, which is also given. Okay. And any side. So AP is equal to AP. So one side is common. So by RHS criteria, the two triangles are congruent, right? So triangle ABP is congruent to triangle ACP. And now simply by CPCT, angle B is equal to,
Angle C.
yes. Okay, then the next topic is not in the syllabus, inequalities in a triangle. So this chapter is over. And so let us start this area related to circle, right? Or I'm thinking, let us do this Heron's formula first, okay? It's a small chapter. Then I'll finish area related to circle. Just 1 minute. Let me open my book. Mm, okay, I have to download it. So anyway, let us start area related to circle then, no issue. Okay, now chapter number 12, areas related to circles, right? Okay. One minute. Okay, right. So let us revisit circles. Okay, we have already learned few things about circles in the previous class. So that's how it's the center O, right? And this length is called the radius that you all know, right? Okay. So in the previous classes, we have learned about area and perimeter of various other figures like a rectangle, square that you have done, right? Triangles. So let us come to area related to circles. Area of circle. Now, what is the formula? Who will tell me? In your previous classes, you have already learned it. Pi r square.
R square.
Yes, pi into r square. So r is the radius as you can see in the figure. Okay. So pi into r square. And perimeter. What is perimeter? Basically, for example, I have a rectangle. What is the meaning of perimeter? Who will tell me? Does anybody know? Say yes or no. Okay, perimeter is basically the length of the boundary, right? So area means this area, which is inside, okay? And perimeter means the boundary length. That means this length, okay? Plus this length, plus this length, and plus this length. So if it is a rectangle, so this is length, right? This is the breadth. This is again length. This is breadth. This is the definition of rectangle, that the opposite sides are equal, right? So what is the perimeter? So one length plus breadth plus length plus breadth, correct? That means 2L plus 2B. And if you take 2 common, so 2 into L plus B, which you remember as a formula, right? So it's not,
Yes.
so it's nothing but the length of the boundary. So in the case of circle, this length of the boundary is actually called circumference. Okay. Circumference is basically the perimeter of circle. That means the length of the boundary of the circle, right? So the formula is 2 into pi into r. So these two you have to remember. All right. And what is the value of pi? This is 22 by 7, and which is taken as 3.14, like approximately taken. Okay. It is not the exact value, because pi, as we have seen in chapter number 1, it is an irrational number, right? It is non-terminating. Remember? You can divide this and see yourself. It will not terminate, But for the calculation purpose, we take it 3.14. Is that okay?
Yes.
Okay. So I think we should come to the question now directly, and then we will see whatever is required here. Okay, first question. So everybody see in your book, first question. The radii of two circles are this and this respectively. Okay. So there are two circles, like first radius R1 is 19 centimeter, correct? And the second radius R2 is 9 centimeter respectively. Find the radius of the circle, okay, which has the circumference equal to the sum of the circumferences of the two circle. Okay, that's good. So what you have to do in this question is, you have to find the circumference of first circle, okay, then the circumference of the second circle, then you have to add it, right?
Yes.
Okay. So you can do it like this. First circle. So your radius R1 is 19 centimeter, right? So the circumference, the formula is 2 pi r. So 2 pi into R1 you will write, okay, R1. So this is equal to 2 into 22 by 7 into R1 is 19 centimeter, correct? Okay. Now second circle. So I'm not doing the calculation, just leave it like this, then we will see afterwards. Now second circle, so radius R2 is 9 centimeter. So the circumference becomes 2 pi into R2, which is 2 into 22 by 7 and into 9 centimeter, correct? Okay. Now
Yes.
find the radius of the circle which has the circumference equal to sum of the circumference of these two circles. So first of all, we will find the sum of the circumference. So sum of circumference is equal to 2 pi r1 and plus 2 pi r2. Basically, this we are taking, right? So like if you don't want to write this, you can leave it here. You can leave this step. You can write it here also, right? So you can take 2 pi common and then it will be r1 plus r2. Is that okay? And now
Yes.
you can directly put the value here also. So 2 into 22 by 7 into r1 is 19 and r2 is 9. So this will make your calculation simpler. So don't put the value here, right? Put it directly there. So otherwise 2 times you have to do calculation. Okay. Now this is 2 into 22 by 7. Okay, this is centimeter, this is centimeter. These are just numbers. Okay. Into, so 19 plus 9, how much does it become? 9 plus 9 is 18 and 28 centimeter, correct? Now 7 into 4 is 28, right? So this is 4.
Yes.
And this is, so this is 44 into 4. 4 into 4, 16. 4 into 4, 16 and 115. So this is 156 centimeters.
176.
76.
Yes, ma'am.
Oh, sorry. Yeah, 176 centimeter. Correct. So this is the sum of circumference. Mhm. Now, according to question, what is given? Now you say that let capital R be the radius of new circle, right? So we denote it by capital R. Now what is it saying? Find the radius of the circle. So capital R you have to find. Okay. Which has circumference equal to sum of the circumferences of these two circles. That means the circumference of this new circle, right, is equal to sum of the circumference of the previous circles, correct? According to question. Understood? Right. So 2 pi into r, and this we have already found. This is 176 centimeter. Is that clear? Now you have to find capital R. So 2 into 22 by 7 into capital R is equal to 176 centimeter, right? Then you
Yes.
take 7 on the right hand side. So 2 into 22 into R is equal to 7 into 176 centimeter, correct? Now this will come in the denominator. So capital R will be 7 into 176 centimeter and divided by 2 into 22. So now you can see if something get cancelled here. So this will be, yeah, I think it can be divided by 11. So 11 into 2, right? And then 11 into 1 is 11. Then 6 will remain 66. So 11 into 6, right? And then again, so 2 into 1 and 2 into 8, right? Then 2 into 1, 2 into 4, sorry, and 7 into 4 is 28. So this is 28 centimeter. Yeah, in NCRT, this is chapter number 12, right? In your book,
Yes, ma'am.
area related to circle, right? Okay. Everybody written?
Ma'am, we're doing Heron's formula.
Hmm.
Okay.
Sorry, what did you say?
Ma'am, this chapter is Heron's formula.
Areas related to circles, right?
Yes.
Heron's formula is a different chapter, isn't it, in your book? Which chapter
Yes.
number is Heron's formula? Can you please tell me in NCRT? I actually have PDF and something is wrong in it, I think. I don't have a hard copy. Can you see the
Heron's formula is chapter 12, ma'am.
and this area related to circles?
Area related to circle, we don't have any chapter like that. It's just circles.
Circles. Okay, I think I have a different edition here, so there is some confusion. Just 1 minute. Let me just check my index. It might be an old version I am having. Mm. Yeah, circles is here. I can see an area related to circle is a different chapter in my book. Okay. And Heron's formula. Just 1 minute. Just give me a minute. I'm just downloading. Okay, actually in the new edition, this chapter is included in the circles chapter itself, I think, right? Let me just check.
Yes.
Hmm. So I can do one thing because we have done only one question so far. So I can start the Heron's formula first, okay? Then we will do this in a sequence. Is that okay? Sorry, there was a chapter name confusion, but anyway, it's okay. Okay, so we will continue with this chapter after this, but let me start Heron's formula now, right? It's a small chapter. Let us finish it first. Okay, now set chapter 12. Heron's formula. Right. Now, see, you have different types of triangle. So you have a right triangle, right? Then you have isosceles triangle. Now try to understand. Then you have isosceles. Then you have equilateral triangle, correct? And you have scalene triangle. What is a scalene triangle?
All sides are equal.
No, all sides are not equal. Equal means equilateral. Okay.
Not equal.
Yeah. So right triangle, you know that one angle is 90 degrees. So it looks like this, correct? This
Yes.
angle is 90 degree. Then isosceles, that means two sides are equal. So at least these two sides are equal, right? Equilateral means all the three sides are equal. So that's the definition of equilateral. And scalene, like no two sides are equal. It can be a triangle like this, right?
Yes.
Okay. Now, if you want to find the area of a right triangle, so it is simple, half into base into height, correct? That is the formula you know so far for the area of triangle, half base into height. So in case of right triangle, this is your height, correct? The vertical, this is height. And if I want to find the area of isosceles triangle, then again I can drop a perpendicular here, right? And I can use Pythagoras theorem. I can find the length of the height and then I can find the area. Similarly, in case of equilateral triangle also, using Pythagoras theorem, I can find height and then I can use this formula. But in case of a scalene triangle, right, it is not possible to find the height, correct? So in such triangles where the height is not given to you, only the length of the sides are given. For example, this side is A, this side is B, this side is C. So in this kind of triangle where there's no height, so there's a special formula which is called the Heron's formula, right? For finding the area of the scalene triangle. So the area of the triangle is given by this under root S into S minus A into S minus B into S minus C, right? Where what is S? Now S is called the semi-perimeter. And S is calculated like this, A plus B plus C divided by 3, right? So first you have to find the semi-perimeter and then you will put this semi-perimeter into this formula to find the uh, area of the circle. So A, B, C are length of the sides. And you have to draw this figure. Is that correct?
Yes, ma'am.
So let us start with the exercise now. So this chapter only has, calculations mainly. It's not tough. Just one formula is there. But you have to be careful with the calculations now, right? So a traffic signal board indicating school ahead is an equilateral triangle with side A. Okay. So there's a triangle which is given to you. It's a signboard on the roads you must have seen, and each side is A. So it's an equilateral. That means all the sides are equal. Find the area of the signal board using Heron's formula. Okay. If the perimeter is this, perimeter is given in this question. 180 centimeter. What will be the area of the signal board? So you don't have to use any other method but Heron's formula, right? So no problem. So according to Heron's formula, area will be under root S into S minus A, right? S minus, now B is also A here and C is also A here because all the sides are A, isn't it? Or you first write the formula. I think it's better to write the proper Heron's formula and then convert it. So the area is equal to, like from Heron's formula, it is S into S minus A into S minus B into S minus C, correct? Now here, what you have, A is equal to B is equal to C, like all the sides are equal. So your area becomes under root S into S minus A. So in place of B also you can write A, in place of C also you can write A. I think this is clear, right? So first you find out
Yes,
what
ma'am.
is the semi-perimeter. So semi-perimeter is given by A plus B plus C by 3. So here it is A plus A plus A divided by 3, right? So this is 3A divided by 3, which is equal to A only. So your semi-perimeter is A. Oh, sorry, one mistake I've done. Just a minute. Sorry, it was not 3. I wrote it by mistake. Sorry. It was 2 in the formula. Please correct it. So it is 3A by 2. Yeah, here also please correct. I don't know why I wrote this. It was 2. Okay. Now you put this in the uh, area. So now the area is under root S. Now what is S? Oh, sorry, not here. It is here is the question. Yeah. So the area is under root S is this 3A by 2. So everything is under square root. So 3A by 2 into 3A by 2 minus of A, right? And then 3A by 2 minus of A, right? And 3A by 2 minus of A. Okay. So separately you can find out this term because it is same 3 times. So just find out how much is this 3A by 2 minus of A. How will you do it? Like take LCM. So 2 is the LCM. So this is 3A minus. So you have nothing here. You have 1, right? So 1 into 2, 2 and 2 into A is 2A. 3A minus 2A, it will be A by 2. Is this clear? Yes. So this will become 3A by 2 into this is A by 2. This is also A by 2 and this is also A by 2. Is that okay?
Yes, ma'am.
Okay, and this first you can split like 3 into A by 2. Can I write it like this thing? And then again I have A by 2 into A by 2 into A by 2, right? Now it's inside the square root, so you can like make pairs and then it will come out. So one A by 2 will come out, then another A by 2 will come out, and then inside the square root we have only 3. Clear? So it becomes I can write under root 3 here and then A square and divided by 4. So this is the area of an equilateral triangle. This is actually a formula, right? You can remember it also. This is what the area of the equilateral triangle is. So we have derived it from Heron's formula. Is it understood, everyone?
Yes, ma'am.
Now in the question it is given, if the perimeter is 180 centimeter, what will be the area of the signal board? Right? So if perimeter is 180 centimeter. Now what is perimeter? Perimeter, I told you, it is length of the boundary, right? So that means A plus A plus A is equal to 180 centimeter, right? So 3A is equal to 180 centimeter and then A will be 180 divided by 3 centimeter, right? So this implies that A is equal to 60 centimeter, right? This is the length of the side. Now, if this is your, you can like mark it 1, result 1. So this area was in terms of A. Now we will put the value of A here and then we will get some number. So putting A is equal to 60 centimeter in 1. Yeah, right? So the area will be under root 3 by 4 into A square. That means 60 centimeter multiplied by 60 centimeter, right? Okay. So you can simplify. So under root 3 and then 1 4 can be cancelled here. So 4 into 1 and then 4 into 1 is 4 and then 20. So 5 times. Okay, so now this is under root 3 and then 15 into 60. 15 centimeter into 60 centimeter. Clear? So this is under root 3 into, now 15 into 6 you have to do. So 0 you can write, and then 6 into 5 is 30. Carry 3, 6 into 1 and 3, 900. And centimeter into centimeter becomes centimeter square. Is that clear? So under root 3 you have to leave like this. 900 under root 3 centimeter square is the area of this equilateral triangle.